HWFCI presents a custom power supply using the XFR1006D transformer. The XFR1006D is available through Jacobs Online following the link below. There are a wide variety of power supplies available through their website, which may be more ideal for your specific project. But the XFR1006D allows for a wide range of nichrome wire gauges and temperatures, all of which are highlighted within this diagram. You can check either Jacobs Online or HWFCI.com for more information regarding nichrome wire and its electrical properties. This power supply allows for two main electrical states. If the power supply is placed in parallel, it will allow for a 6-volt output with a maximum of 16.7 amps, whereas if the power supply is placed in series, it will allow for 12 volts at 8.3 amps. The purpose of this tutorial is to show you how to create the added components to regulate the voltage output from this power supply, and therefore gaining control of the temperature for your nichrome wire hot wire foam cutter. As a disclaimer, it should be noted that you should proceed at your own risk. This tutorial is meant to be a general guide only, and we in no way take responsibility for loss or damage of personal goods nor personal harm. This tutorial is rather advanced and requires knowledge of electrical circuits and properties. Please proceed at your own risk. The following diagram is the electrical circuit for this custom power supply. It is available through our website for download. While there are many different circuits that can be constructed, this seemed to be the most ideal circuit for our project. But before proceeding through this video, it is important that you take a few minutes and study this diagram well. When working in a tight space, it is sometimes difficult to identify all of the electrical wires within the power supply. But knowing the general concept and flow of the electrical circuit, you will be able to efficiently construct this power supply as well as troubleshoot problems in the future. You should notice that this supply has an inline fuse to prevent damage to the power supply. There is also a dimmer switch that will regulate the output voltage from the transformer, which therefore regulates amperage and temperature. The main control for the transformer is a double pull, double throw toggle switch. This switch regulates between a series or parallel circuit, but think of this component as providing a high and low setting for the power supply. As you can see, when the toggle switch is thrown to position A, it is placing the power supply in parallel. This means that the positive leads are connected to each other and the neutral leads are connected to each other. Whereas with position B, the circuit is placed in series. This means the positive and neutral leads are stacked on end. In other words, positive to neutral, linked together as a daisy chain. You will notice that the last neutral wire is not connected through the switch. Keep in mind that the electrical current flows through the hot wire foam cutter and utilizes this last neutral lead as the main neutral lead return back to the power supply. Again, it may behoove you to print off this diagram from the website and follow along as you proceed through this tutorial. With similarly colored connection wire, you may get lost as wires are connected and stripped. And now a quick parts list. You will require a 15 amp 1-pole toggle switch with pilot light, a Lutron dimmer switch model number D-600R, a double pole, double throw, on-off-on toggle switch. You'll need a male extension cord end, a fuse holder with 1 amp fuse, panel mount binding posts, XFR1006D step-down transformer, a triple gang box, 10 inches of 2x4 plank wood, 14 gauge stranded connection wire, approximately 10 feet, a length of 14-2 electrical wire to be used as the main extension, and appropriate faceplates. As we proceed through this tutorial, know that some of the more obvious steps are excluded, and some of the more tedious steps are sped up to save on overall length of time. The first step is to plan the basic layout for your power supply. Once the transformer and electrical box are in place, you can start to plan the placement of the drill holes for the fuse holder and all electrical wires. Once the layout is established, start by attaching the transformer to the wooden block before you attach the electrical box. This may be unnecessary, but by attaching a length of electrical wire to the outer casing of the transformer, you are establishing a main ground for your nichrome circuit. Using a washer on the screw that is going to go into the wood may help hold the wire in place. Now that the transformer is secured to the wood, it will be much easier to place holes into the electrical box before attaching it to the main block. Start by carving out the main supply hole for the 14-2 service wire. You may use a metal file to clean up the defect. A large hole will need to be drilled for the fuse holder. It is recommended to be placed towards the bottom of the box to stay out of the way of the other components. All manufacturers will suggest drill bit sizes, but this one requires a 1/2-inch bit. Using a smaller bit, a guide hold may aid in proper placement. If you are unsure of drill bit size, you can always select a bit that covers the threads of your fuse holder. Similarly, holes will need to be drilled which will allow passage of the transformer wires into the main electrical box. Remember to place them towards the top but low enough as to not interfere with other future components. Around 1 inch should be sufficient. With all holes made, the box is ready to attach to the wooden block. But first, it will likely be easier to pass the transformer wires into the box prior to attachment. And now attach the electrical box to the wooden block. Take the ground wire and feed it through the service hole, then pass the main service wire. Inside of the electrical box, around 4 to 6 inches of service wire should be sufficient, but you can always trim the excess if you want to include more. Then, using cable staples, secure the service and ground wire to the wooden block. Make sure the wires are snug, but a second staple should be placed to act as a backup. And now the fuse holder. Remember that this fuse holder is a bridge between the main service wire and the rest of the circuit. When the fuse breaks, all power is cut to the circuit and the transformer. The service wire attaches to one terminal, current flows through the fuse and exits the remaining terminal. Wires will need to be attached to each of the terminals and attached as noted in the diagram. Depending on your fuse holder, the 14 gauge connection wire may be larger than the holes in the terminal. Separate the lead and shorten one length of wire. This allows for the longer lead to pass through the terminal, then wrap around the bulk of the connection wire. Once the wire is wrapped back onto itself, a bit of solder will help keep the wire from fraying and dislodging at a later time.
Then place a bit of electrical tape to separate the terminals and prevent short circuiting. Replace the included washer, then place the fuse holder into the electrical box. Replace the second washer and the main nut to secure the fuse holder to the electrical box. With all the main wires inside of the electrical box, this is an opportune time to organize the wires into groups. Leading clockwise are the transformer wires to attach to the main service, transformer wires to attach to the double pole, double throw switch, wires from the fuse holder, and the main service wires. Not to forget the ground wire from the transformer casing leading into the main service hole. And now the double pull, double throw, on, off, on toggle switch. With this power supply, it is recommended to start at the transformer and work towards the fuse holder. The toggle switch is much more meticulous and will become difficult to work with if all the other components are already in place. On that same note, this is the more tedious portion of the tutorial, and being familiar with the electrical diagram will help you follow along. With this switch there are three states, on, off, on, but we will designate one side as A and the other as B. Typically, the left and right sides do not communicate with each other, allowing for one side to be positive terminals and the other side to be negative. Each toggle switch may be different, but using a multimeter you can figure out which terminals are connected when the switch is thrown. The center terminal is a common terminal, so when testing the switch, make sure that it is always connected to your multimeter. With this switch, when it is thrown in the opposite direction, it activates the opposing terminals. So as you can see, using a multimeter helps assess how the switch works to ensure proper circuitry with our project. If you have not done so already, you will want to mark your switches A side and B side. This will help reduce confusion as we go through the remaining steps. You may also want to mark the top of your switch to remind you once assembled into the electrical box, as you will not be able to see which side is clearly marked A and B. Start by removing the nut and toggle plate, then grab the electrical faceplate and mark a hole for drilling. This switch calls for a 1/2-inch drill bit, but a guide hole may help ensure proper placement and reduce breaking of the plastic. With this type of soft plastic, it is best to drill slow and controlled. Once the switch is in position, replace the toggle plate and nut. But before moving on to wiring the switch, attach the panel mount banana jacks to the electrical faceplate. These types of jacks were selected because they not only accept banana jacks, but also have a screw terminal for placing bare wires onto your electrical power supply. Start by removing the nut and lock washer, then determine placement on the electrical faceplate. When selecting placement, remember the jacks will need to fit into the electrical box and not contact any other underlying wires or components. Then place the terminal into the faceplate and replace the lock washer and nut, but take care to not strip the plastic when securing the nut back onto the terminal. Now that all the components are attached, mark the faceplate on the underside to designate a positive side and a neutral side. You may also want to redesignate side A
and side B. Now that we're ready to wire the switch, place all unnecessary wires out of the way. You'll also want to refamiliarize yourself with the transformer wires that will attach to the toggle switch. It is very important that you keep the positive and neutral lines separated into pairs which correspond to their placement on the transformer. Next, take the transformer wires that will attach to the electrical service and designate one of the leads as positive and the other as neutral. This can be done by marking one line with a black permanent marker for reference. Take a length of stripped connection wire and attach it to the neutral line from the transformer and the neutral line from the main 14-2 service wire. The neutral lines will not be necessary until later in this tutorial, but it's best to perform this step now as to bury the wires out of the way. Tape all unnecessary wires to one side as to not confuse and give more room to work with the electrical toggle switch. Attach another length of connection wire to the positive transformer wire, which will later be attached to the dimmer switch. Bury these wires and place aside for now. Don't forget to mark this as the positive lead with your permanent marker. You will now require 4 lengths of connection wire and 2 additional wire nuts. Take the blue-black lead and attach 2 lengths of wire with a wire nut. Place the wires out of the way and then mark them as positive. Take the yellow neutral wire and repeat the previous steps by attaching 2 lengths of connection wire and burying out of the way. The blue neutral and yellow black positive wires should remain. These will attach to the common terminal on the toggle switch, but remember which sides of the switch are designated as positive and those as neutral. Take care as to not reverse their placement. Start by attaching the blue neutral wire to the common neutral terminal on the toggle switch. Then attach the yellow-black positive wire to the common positive terminal on the toggle switch. Take one of the connection wires that is spliced to the yellow neutral wire and attach it to neutral side A. Similarly, take one of the connection wires spliced to the blue-black lead and attach it to the positive side A. You may want to reposition the electrical wires so that they do not become tangled when the toggle switch is replaced into the electrical box. The last step with the toggle switch is to place a small jumper between the neutral and positive terminals on side B. Here you can appreciate the final product, but be sure to clean up any stray copper strands to prevent short circuiting. Take the remaining electrical wires that are spliced to the blue-black positive lead and the yellow-white neutral lead and attach them to either of the panel mount banana jacks. It doesn't matter which side the wires are attached. Wrap the electrical wires around the terminal but between the 2 hex nuts and secure tightly. Using a bit of solder, secure the electrical wire to the hex nut and the terminal. Simply repeat this process for the remaining electrical wire and banana jack. Here is the final product, which is ready for placement into the electrical box. Before moving on to the dimmer switch, attach the faceplate mounting bracket onto the electrical box.
Now that the toggle switch is finished, the remaining components may be added to the electrical box. Next up is the Lutron dimmer switch. This will need to be attached to the transformer's positive lead and an additional connection lead that will attach to the pilot light toggle switch. Start by taking the positive connection wire that is marked and spliced to the transformer positive lead. Trim the excess and strip appropriately. Then take one positive lead from the dimmer switch and attach it to the transformer connection wire. Then bury the spliced wires into the electrical box. Then attach the dimmer switch to the electrical box, making sure to keep the remaining positive lead and ground wire towards the fuse box and 14-2 service wire. Attach the faceplate and make sure the dimmer switch will line up properly. With the dimmer switch installed, you will be splicing the ground wire from the main 14-2 service, the forced ground from the transformer, and the ground from the dimmer switch together. You will also need to add a short jumper ground which will attach to the pilot light toggle switch. There are 4 wires in total. Splice all of the grounds together and bury within the electrical box, which should be held secure by the overlying dimmer switch. Next, the positive leads from the fuse holder will need to be spliced into the circuit. Take the positive lead from the 14-2 service wire and attach to one lead from the fuse holder. Once stripped and bound, bury the cables under the dimmer switch. The circuit is now ready for the 15 amp toggle switch with pilot light. There are a few ways to wire these switches, but the intended purpose is for the light to come on when the entire circuit has power. The remaining wires include the last positive lead from a fuse holder, the spliced neutral and ground jumpers, and the last positive lead from the dimmer switch. Take the toggle switch and identify the neutral terminal and the 3 positive terminals. The neutral terminal is almost always a silver screw, whereas the positive terminals are almost always brass screws. Take the positive lead from the fuse holder and attach it to the terminal located next to the neutral terminal on the toggle switch. Then take the spliced neutral wire and attach to the silver neutral terminal on the toggle switch. Then trim and attach the spliced ground wire to the toggle switch. A jumper connection wire will need to be attached to the positive terminal immediately adjacent to the toggle switch. Take another length of connection wire and attach to the positive terminal on the pilot light. Take these 2 jumper leads and remaining positive lead from the dimmer switch and splice together. This bundle of wires should then be buried into the electrical box. Some manipulation of all remaining toggle switch wires will be necessary to fit this component into the electrical enclosure. Attach the remaining faceplate and manipulate to fit the end toggle switch into place. Then attach the entire faceplate assembly to the electrical box. The last component is the male extension cord end, which will attach to the 14-2 service wire. You will need to start by disassembling the connector. You will notice the neutral terminal is a silver screw and the positive terminal is a brass screw. Located on the bottom is the electrical ground. Strip the remaining end of your 14-2 service wire, exposing all 3 cables. Trim and strip to fit. Remember that you'll need to place the outer male casing before you attach the male connector. You can assemble the connector in any order that you wish, just make sure that all connections are tight. You can now see the positive lead is attached to the positive brass terminal, the neutral lead is to the silver terminal, and the ground is to the green terminal on the bottom. Replace the outer casing and secure in place with the provided screw.
Last but not least, place the dimmer switch dial onto the dimmer switch and turn to the off position. Mark this off position for future reference. Then turn the dial to 100% on and mark this position as well. You may want to take some time to label the remaining components on the faceplate. Remember which direction on your double pull, double throw toggle switch activates side A and side B, as this will place your power supply into series or parallel, which allows for a low and a high power mode. It is a good idea to test your power supply to ensure it is working properly. Attach a multimeter to test for alternating voltage, then attach the power supply to a cutter. Throw both toggle switches, then gradually increase the dimmer switch. Set to circuit A, this applies 6 volts to the cutter. Using the dimmer switch, you'll be able to fine-tune lower voltages, which becomes important when you're dealing with a large gauge nichrome cutter. When turned to 100%, you'll notice that the power supply achieves near 6 volts. Setting to circuit B, the power supply will output 12 volts, but tolerates a lower amperage. This higher voltage setting is important for smaller gauge nichrome wire or cutters that have longer lengths. As you can see, around 11 volts are achieved. With the toggle switch set to the off position, the power supply is not engaged. And there you have it, a custom power supply using the XFR1006E step-down transformer acquired from Jacobs Online, a leading supplier of nichrome wire. This power supply should be able to power all hobby foam cutters, including the larger vertical tabletop cutters, but also the large gauge bendable nichrome wire hand cutters. It is important that you select a power supply that is adequate for your specific project, but this power supply should be more than adequate for all practical uses. And thank you for watching. Check out all related information on hotwirefoamcutterinfo.com.